Good morning, mathematicians. We are taking a look here at our cool down where we're going to find the value of these expressions. And certainly we're going to have products that extend to the hundredths place. So let's go ahead and take a look at number one. Notice in number one, we have 3/10 times 6/10. So we are going to use our diagram and we're going to use the columns first to show 3/10. So we're going to show 3/10 of this particular grid. Now to show 3/10 of this grid, we would highlight 3 of the 10 columns. So here we go. I have highlighting in 1, 2, 3. I am seeing 3 of the 10 columns shaded, which is where we see our 3/10. Now I'm going to show 6/10 horizontally. I'm going to show 6/10 because I'm going to have 6 of the 10 rows with shading. So here's 1, 2, 3, 4, 5, 6. Now this works because we're not taking 3/10 times 1. We're taking 3/10 times something less than 1, which means we're not going to get a whole group of 3/10. We're only going to get 6/10 of 3/10. So we're only getting a portion of it. In fact, our answer to what 6/10 of 3/10 is lies right here in the particular part of this flat grid that has the overlap. Where I see the blue and red plaid, that's where the answer is. That's what 3/10 of 6/10 is, or 6/10 of 3/10 is. That's where we find our answer. So boys and girls, what we have to do is we have to come and actually take a look at how many of these particular hundredths have overlap. Now, I see that this is a 6 by 3 array, which means there should be 18 individual squares in here. Sure enough, there are. I could count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. But again, from here on out, you also can look and see, well, this is a 6 by 3 array. Now, because of this, I know that 3/10 times 6/10 is 18, but 18 what? Well, there are 18 individual squares, and those individual squares communicate the hundredths place. So my answer to this question is right here in this gold rectangle. 3/10 times 6/10 equals 18 hundredths. All right, let's go on down and let's use similar thinking, but with our question number 2. And one big thing that I noticed that is different in our question number 2 is one of my factors is greater than 1, right? So my very first factor that I have is 1 and 3/10. So I am going to be showing 1 and 3/10, but I'm going to have to use this other square over here, because I know that if I'm going to be showing 1 and 3/10, then really this entire area is going to be highlighted, because this is that 1 that I need, but now I need 3 of the 10 columns in the next grid as well. So now take note, I see 1 and 3/10 vertically in the columns. I actually have 13 columns with shading because there are 13/10 in 1 and 3/10. Now I'm ready to show my 6/10, which actually is the exact same factor that we had above. So we are going to be showing our 6/10 in our rows. So I'm now going to show 6 of these 10 rows with shading. There's 1 and 2 and 3 and 4 and 5 and 6. Now remember that when we multiply, particularly when we multiply decimals, but also fractions, and even with whole numbers, multiplication does not always make things bigger. like we may have been told in previous grades. That's really not true. Instead, multiplication is like a scale. I am not taking all of this 1 3/10. I'm only taking 6/10 of it. So 6/10 of 1 3/10 is going to equal here where we see I just put a green box around it because this is where our product is, right? So that is where truly our answer lies. So I know that 1 3/10 times 6/10 is going to equal whatever is in this green box. Now I see an array, and this array is a 13 by 6 array. Now 13 times 6 is not something that you memorized in previous grades, but we can quickly do this. 6 times 3 is 18. 6 times 1 is 6 plus 1 is 7. There should be 78 single squares in our overlap area. And I could literally sit here and count them off, but yes, you're going to find that there are 76 individual squares. Now those individual squares communicate the hundredths place. So this is how we're going to show that our answer is reflected as 78 hundredths. Boys and girls, we have shown this as a representational model on the grids. And we've also shown it as an abstract model just with the equation that we built. And by doing that, certainly we found the value of the equation and we found it in multiple ways. That finishes out our lesson 20 cool down.